So 5.6, inverse relations and functions. So we were doing composite functions yesterday because we have to do composite functions to find inverse functions. So what is an inverse function? Which one is represented by it? Okay. They interchange domain and range. So if the function is this x and y table,
What is that?
okay, so this is the function. This is f of x. So f inverse of x, that means inverse. Interchange, whoa, that's horrible.
It's okay, you got this. Just redo it.
Interchange your domain and range. So domain and range is x and y, yes?
Yes.
So just switch them. So it's not negative 2, 1, it's what?
1 to negative 2.
1, negative 2. 4,
Negative
negative
1.
1. 3, 0,
1,
1. Okay, do this one on your own. So this is F. So this is F. No, on your own. Like, quietly.
Okay. I already have it.
Good.
How was your weekend? Last weekend?
Jenna, please do it, please.
It's fine.
So Noah, what'd you get?
So for the X's, we got 9, 7, 5, 3, 1, negative 1. Y, negative 1, 0, 1, 2, 3, 4.
Okay.
I have a question.
What?
Instead of knowing just to flip them, what if you didn't know that? What math would you have to perform to get the answer?
Inverse functions, and then you'd have to plug in points.
Yeah, I don't get it.
So you haven't even gotten there yet. You wouldn't get
You
it.
need to focus.
Can you let me?
Lock in.
Okay, City, let me get there. There's pieces, okay? Okay, so inverse functions just interchange range and domain. The domain of one is the range of the other, range of one, domain of the other. They are inverses of each other, so it wouldn't matter which one. If I said this was F, then this would be F inverse. It wouldn't matter which one's which. You would still get the same answer. Okay, to find an inverse relation of an equation, you interchange x and y and solve for y. This is important. This is important. To find an inverse relation of an equation, interchange the x and y, then solve for y.
I was facing out. What's wrong?
Both you and Reagan go, oh, I'm supposed to write this down. Right at the same
At
moment.
the same time.
Mm-hmm.
I was thinking.
Logan still hasn't figured that out yet.
I have to write it down.
Oh, that's...
There's a star by it, Logan.
And it's in bold.
Only if you. Listen to me. Only if you.
Bless you. Bless you.
Just look for Austin.
Doesn't have a team, just
Yes, it does.
has the team and a number of qualifiers.
And it's has one.
Okay, so on there, I have find the inverse of f of x equals x squared. There's no y. Or is there a y?
There is
Where is it?
not.
Isn't f of x the same as y? Okay, so this is y equals x squared. Yes? Okay, so it says, do what? How do I find an inverse? What's it tell you? Right here, what's it say to do?
What is that though? What is it?
Interchange x and y and solve for y. So this y becomes a, this y becomes a,
X,
and this x becomes a
Y.
y. So I have x equals y squared.
How would you solve for that?
How would you solve for that?
There's nothing to solve.
You would switch them and square that number. Like,
X squared.
so
is
say
equal to
y was 3 and x was 4. You would switch it so it'd be 4 equals 3 squared, so it'd be 4 equals 9.
Huh?
I think I'm wrong.
Yeah,
Like,
because.
in my brain, it works.
Okay, we solved equations like this. How do you get rid of a square? We square root it. So you square root both sides. So we have.
Equals square root of X.
Shh. So you have y equals plus or minus the square root of x. Because when you take the square root, it's both. So this is f, so this is f
Of
F
X.
inverse. That little -1 is inverse. Okay, F inverse is this. And it says, what do their graphs look like? Okay, so we probably should draw some graphs, right?
Huh?
The next part of that says, what do their graphs look like?
there isn't graphs to look at.
So you have to make them. No, you guys are going to make them. What does x squared look like, guys? It's a
0,
It's a
0.
parabola. It goes through 0, 0.
Yeah.
And then when I plug in 1, I get 1. When I plug in -1, I get 1. When I plug in 2, I get
2,
no. No. When I plug in 2 to x squared, what do I get?
4.
4. And then if I plugged in -2, I would get
-4.
-2 squared, you get 4.
Well, that's it.
Okay. So it looks like a parabola, yes?
Yeah. Now you just have to draw the line. These scare me.
Okay. So now let's look at the inverse. We're going to make a table. Here's x's and here's my y's.
I remember doing this.
Because it says, what do the graphs look like? Okay, so give me an x. Can I be anything negative?
Yeah.
You can't take the square root of a negative number. So can it be anything negative? No. So I better start with 0. And it's plus and minus. Well, the square root of 0 is
0.
0. And there's no plus or minus to it, is there?
No.
No. Okay.
1.
Okay. Plug in 1.
You get
Plus or
1.
minus 1.
I get plus or minus 1.
Yeah.
If I plug in
2.
not 2,
Why?
4. Why 4?
Because it's a square.
It's a perfect square.
4.
I thought we're
you
squaring
get
the number.
plus or
No,
minus
we-
2.
City,
Are we taking the square root of it? Or
what does the equation say to
What
do?
does that look like?
square root? But
Square root.
whenever we were squaring it.
Well, because that says what?
Squaring. How do you
How
get
do
rid
I
of the
know
square?
which equation
City,
I'm
how do you get
supposed
rid
to
of the square?
Stop.
Square root.
Okay, we have
know
to,
that.
because we have to graph both. This is f of x.
But why aren't we graphing that one?
We have to graph both.
So why are we
Plus or
doing a
minus
table?
2, man.
Because we don't know what the square root of x looks like. Well, you should know what the square root of x looks like, but
Plus or minus 2.
This isn't
plus or minus 2.
And you could do like
9.
9.
Plus or minus 3.
Okay, so plus or minus 3. And we're going to stop there.
I
Okay?
don't think we should. 16.
So,
4. So you're
we're going to
supposed
graph.
No, like there's a thing.
So 0, 0, 1, and then I go positive 1 and
Positive 1. Plus or minus 1. That's what it says.
okay, I'm just
I wasn't
so
going-
plus or minus 1. When I plug in 4, what did I get? Plus or minus 2.
What's going on with all the little dots?
I'm plotting the points. I'm plotting the points that we found. Okay, I don't have room for 9. I'm not doing 9. Does that work?
So this one isn't making a parabola.
We'll see.
Oh, it is.
Jenna, can you please turn around?
Yeah.
Okay, so it goes here and it goes where?
Here. There.
So it can make it in a different direction.
Okay, so
It does.
every inverse will do the same thing that this one did because we interchange the x's and y's. So on f of x, when it was 2, we got 4. But on f inverse, when it was 4, we got 2. We interchange those. They actually reflect across the y equals x line. So they reflect across y equals x. Well, what's the y-intercept of y equals x? Isn't it 0?
Yeah.
Yes. What's the slope? Y equals x. What's the slope?
1.
1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1.
I know.
So every single one will reflect across this line.
Oh. Where'd you get y equals x though?
I'm just telling you that. I'm telling you that it reflects across that line. It's called the identity line. Every single, and if I graphed it better, it would go. I'm sure I have one that does. Every single graph that are inverses of each other reflect across that line because you're interchanging the domain and the range, the x and the y.
They don't reflect over the x.
No, they reflect over y equals x.